Hello, everyone. Thank you for attending my presentation on deploying Jamf and Munki in a lab environment. My name is Keilson. This is my first time speaking at PSU MacAdmins. I've been in Thank you. I've been in the IT industry for 12 years professionally as a MacAdmin, 10 years of that specifically in higher education, and 5 years at my current employer at Ringling College of Art and Design. I've attended PSU MacAdmins in 2019 and 2023, and virtually 2020, 2021, and 2022. So the agenda for today is to give an introduction on what Jamf and Munki are, how they can work in your environment, kind of give an overview of them, benefits of combining both items, setting up Jamf and setting up Munki, integrating Munki with Jamf, deployment strategies, best practices, and Q&A. So, show of hands, how many of you are currently managing Macs with Munki? Okay, it's a good number. And how many of you are using Jamf as your MDM? Okay, a lot more hands. Perfect. And how many of those groups do you manage lab machines as well? Okay, lab machines, yes. Okay, it's a good number. So let me start with an overview of my current employer, Ringling College of Art and Design. So we were founded in 1931 as a remote branch of Southern College, separated in 1933 to become an independent nonprofit institution. The School of Fine and Applied Art of the John and Mabel Ringling Art Museum was renamed the Ringling School of Art and Design. And the first class only had 75 students and 13 faculty members. There were 13 faculty members at that time. One thing that Sarasota is also known for is the Ringling Brothers Circus. So that's their winter headquarters. So that's where the name John Ringling is related to. So Ringling College has over 1,700 undergraduate students. We offer 13 degree programs. The college is the only institution in Florida dedicated to teaching art and design, and many of our programs are linked to, are ranked among the best in the nation, including computer animation, motion design, and game art. Of those 13 degree programs, they include the business of art and design, computer animation, creative writing, entertainment design, film, fine arts, game art, graphic design, illustration, motion design, photography and imaging, virtual reality development, and visual studies. Each year, the Ringling College Center for Career Services works tirelessly to bring the biggest and best companies to campus for one-to-one interviews and portfolio reviews. It's no wonder our graduates go on to work at many of the world's leading art and design companies. Here are a few that hire our students. And then, as I said before, we're located in Sarasota, Florida, alongside the Gulf of Mexico. We're minutes from some of the world's best beaches, including Siesta Key. We're about an hour south of Tampa and Fort Myers, and 3 hours from Miami. Our students come from over 60 different countries. 22% are international. And our Mac lab fleet on campus consists of over 500 devices. They range from Intel-based Mac Pros and iMacs, Mac Minis, and feature our newest Mac features the Mac Studio with M2 Ultra processors, 24 cores, 76 core GPU, 128 gigs of memory, and each desktop either has a 27-inch Wacom Cintiq for drawing or a 27-inch LG 5K display. So managing Macs in educational environments presents several different challenges, including diverse user groups. So students and faculty have varying requirements. They need flexible but secure configurations. This extends to different computer labs and configurations for the different departments. That includes printers, settings, etc., that keep those different labs up and running. Software deployment. So we need to ensure that all the devices in those labs have the necessary software that's designed for that particular area. We need to make sure that versions are kept the same across the different areas. We also need to make sure that specialized software is only available in certain labs because they are license restricted based on the number of seats. So we need a solution that can handle the deployment of that. We also need to manage security. So protecting the sensitive student data while also allowing the necessary robust security measures and monitoring of the lab machines needs to be encompassed in this environment. So we monitor the computers with Jamf. We use user profiles for the creation of the computer session, and then upon daily reboot, those profiles are cleared and the students are able to basically restart on that machine as if it was, seamless from the ground up. So in our setup, because the machines are wiped, we provide a local scratch disk that allows the students to work on their projects while using those computers. And then they use a network home space that we provide that essentially mounts when they log in, and that allows them to save files between the computers or carry them between the computers, and also between Windows and Mac. They can switch between the different labs and access those same files. So device enrollment and configuration, we also need to automate the setup and configuration of the new devices to ensure that they are consistent and in compliance with the college policies. Updates and maintenance, we need to regularly update the operating system and applications without disrupting the learning process. Support and troubleshooting, so we need to provide timely support and resolving technical issues to minimize downtime for users. We need to do this seamlessly so we're not impacting students while they're using those lab machines. And these challenges require a plan that balances the ease of use and functionality while still offering flexibility for the students and faculty to use the computers for teaching and learning. So efficient deployment and management tools are essential in educational environments to ensure smooth operations, maintain security, and enhance the overall user experience. Specifically, they help in scalability, so we need to easily manage a large number of endpoint devices across different locations. Our campus has two different physical locations, but we have a number of different buildings on campus, so again, we need to make sure that everything's consistent there. Going into consistency, we need to make sure that everything is uniformly configured and equipped with the necessary software and updates. Time savings, we need to automate the routine tasks to free up IT staff for more critical issues. Security, quickly deploying security patches and enforcing policies to protect sensitive information. And the overall user experience, minimizing downtime and disruptions for students and faculty, enabling them to focus on teaching and learning. So let's start with an overview of what Jamf is. So Jamf Pro, it's a comprehensive management solution designed for Apple devices. It allows IT administrators to manage and secure Mac, iPad, iPhone, and Apple TV devices. Jamf Pro is widely used in educational environments, businesses, and government agencies to streamline the management and security of Apple devices. Some of the key features include automated device enrollment, streamlines the setup for new devices with zero touch, application and patch management, deploys and manages applications, patches, updates across devices, configuration profiles to enforce the security policies and configurations consistently across devices, inventory management provides detail and hardware software information for all managed clients, a self-service portal to empower end users to install pre-approved applications and resources on their own, and security and compliance. So ensures the devices with security policies and regulations are equipped through continuous monitoring. How does Jamf work? So you need to enroll a device first in Jamf. It can be enrolled manually or via Apple Business Manager or Apple School Manager. Then we need to install profile and policies. So configuration profiles are configured in Jamf, and policies are pushed to enroll devices. Applications and updates then are deployed and managed through Jamf. And we'll get to that in a minute because I'm talking about Munki here. But monitoring and reporting, IT staff need to monitor device health, compliance, and usage through a centralized dashboard. and the support and maintenance, so provides remote support and troubleshooting capabilities. So now we'll provide an overview of what Munki is, starting with what is Munki. Munki is an open source software deployment and management tool for macOS. It was developed by Walt Disney Animation Studios and is widely used in educational and enterprise environments, primarily written by Greg Nagel. It supports packages, scripts, and .app format applications for deployment. And a set of tools that are called Munki tools are installed on the client Macs and run a launch daemon that checks every hour for software. Some of the key features of Munki include the automated software deployment, streamlines the process of installing and updating software across multiple devices. Then it supports software catalogs and manifests, which organize the software into different catalogs and defines what gets installed on different groups of machines. It supports a client-server architecture, which uses a central repository for managing software packages, which clients fetch upon. It's customizable and extensible and allows for customization to fit specific needs and extended with scripts and additional tools. And it provides a friendly user interface, a managed software center, that allows users to install software that is hosted through Munki. Some of the benefits of using Munki in educational environments includes the consistency, so ensuring that all of our lab machines have the same software version and configurations. Every hour, the computers check in for the software updates. We need efficiency to reduce the time that IT staff spend on manual installations and updates. We have a few labs that do require some of that, so we always try to strive for the automation. Scalability, so we need to be able to scale to hundreds or thousands of devices, depending on if we bring on a new lab, bring on new computers, we need to be able to keep the deployment consistent. And it's cost effective. So by its open source design allows us to make it budget friendly in our environment. How does Munki work? So we need to create software packages. So we create software packages that can be deployed. Receipts or pre-install scripts are what are used to determine if a package is installed. We then upload those packages to a central repository. We define manifests, which are specifically created for the devices, the end devices, and we tie those packages to those manifests. For our purposes in our environment, we base our manifests off of host names, which are basically the lab computer names. So this ensures that when a computer changes identity, the packages stay with them wherever they go. You can use serial number, depending on your organization's requirements, or client IDs. And then the client machines fetch updates, so they're going to regularly check the repository for updates and install them as needed. Typically, this is a random interval at every 60 minutes. The launch daemon, upon install, will actually randomize a number between 0 and 59 to determine that random interval, and that's performed using the managed software update agent. The agent runs the install checks, and if the machine needs to download and install the update, it will do so at that time. Some of the benefits of combining Jamf and Munki include the comprehensive management. So for us, Jamf handles the device management, including the enrollment in School Manager or Business Manager, while Munki handles the software deployment. The enhanced automation, so smart groups within Jamf Pro are a game changer for us. We're able to scope specific configurations to labs and update the DNS hostname of the computers outside of this process and ultimately change the computer's identity. That allows us to move machines across campus without having to fully wipe and redeploy. We can simply change the host name, flush a policy, the computer obtains that new identity, software is removed, and the new software is installed. We typically run our environment on a production life cycle, so we'll lock down versions during the summer. Those versions will be locked down, we'll test them, and then come fall, they'll be in use for the fall semester, the spring semester, and then we repeat the process next year. That keeps things consistent. We occasionally have problems when we run through the setup where a bug will be found during the deployment or during the use of a program. So when that happens, we have to identify and apply the security patch or apply the fix live. And we have to do that in a way that is lessened on both the IT staff and doesn't disrupt the teaching environment. So some of the benefits include also the cost efficiency. So because we are located in Florida, we do, as you know, the Tampa area especially can have very inclement weather. So we're considered the lightning capital of the world. So we maintain a number of servers on campus to help ensure that our image is consistent should we lose internet. However, devices that are already staged in our environment, we can't go ahead and just wipe, especially during that time, because it then has to go through the pre-stage enrollment. So that's why we typically use Munki in that case, because we can rename the host names and keep those machines enrolled while still deploying the necessary software and ensuring that when our connection is restored, we're back online. So, and we need it to be scalable. So we need to be able to scale multiple labs or image multiple labs at once, avoiding touching each machine at a time. So now that we know the benefits of combining Jamf and Munki, let's talk about how to do it. So in our environment, our core function is DNS. Everything's based on DNS. So let's talk about DNS from a high-level overview. So this is the RFC 1034. DNS is defined as a distributed, hierarchical, and loosely coherent naming system for computers, services, or any resource connected to the internet or a private network. So we're going to be using DNS to name our lab machines so they can easily be found in both physical and virtual systems. Here's an example of a host name that we have. We're going to break it down and explain the different sections. So we have three different parts here. We have the location of the computer, such as the building or the classroom, the number of the computer in the lab for easy identification when students report issues, and the suffix, ensuring that the computer is part of our fleet. This usually includes a subdomain or like a site code. We usually match that to our site in Jamf, so we can easily identify which machines are scoped to which area. Each computer has a sticker with this information, and it's also available on the desktop. That allows us to maintain these internal records and change those computers' identity without having to involve a reimage process. So we're first going to go into Jamf here. We're going to go into Settings, select Global, and click on Automated Device Enrollment. So this is going to get our Macs enrolled in Jamf automatically. Once you click on Automated Device Enrollment, click on Public Key, and you'll want to save this file to your computer. We're going to use that in just a moment. So as you can see, we utilize multiple sites, and we have separate ADE setups. So now click on New. We're going to enter a name here that's recognizable. I like to use the site that we're working with. And then we're going to switch gears here and open a new tab and go to school.apple.com. If you're education, if you use Apple Business Manager, you'll use business.apple.com. Once you load those web pages, then you'll need to navigate to Preferences, scroll to your MDM servers, click Add, and you'll want to provide a name for the MDM server to decide if you want to allow the MDM server, Jamf Pro, to have the ability to release devices from ASM or ABM. And then under the server settings, you're going to click Choose File and select the public key that you downloaded previously from Jamf Pro. And then once done, click Save. And then you'll see the MDM server is created. So once the MDM server is created, you're going to hit in the upper right corner the Download MDM Server Token. And that is what we're going to use in Jamf Pro to assign devices to this instance. You can also change under the default device assignment, you can change the type of machine to automatically enroll if you always have Macs that are only going to be associated with a single site or a single MDM instance. You can do that here. So we're going to take that token then and choose the, we're going to click on the Upload Server Token file, and then we're going to select that token. Once that's done, then Jamf and Apple School Manager or Business Manager will start communicating, and they'll assign devices to your Jamf Pro instance. So now we're going to go back to settings here, and we're going to create a pre-stage enrollment. And what we're actually going to do is, I must have my notes messed up here, we're going to actually create the packages before we create the pre-stage enrollment. So we're going to go back to settings, click Computer Management, and then go to Packages. And then we first need to upload, to incorporate Munki into our environment, we need to upload the Munki Tools package. So that is when the pre-stage enrollment kicks in, the Munki Tools package will get installed as part of that process before any other software is deployed to that machine. So we want to make sure that Munki is triggered immediately after the computer finishes the pre-stage enrollment and before students and faculty start using the lab machines. You can get this from the Munki GitHub repo. I like to add notes in on the Jamf side of who uploaded the package, the date the package was uploaded, and it's nice to have the version information listed there for others to see. Keep in mind that this package is unsigned and not notarized, so that should install without requiring a restart from a newer version of Munki, but you may have problems installing it as part of the pre-stage. So the Mac Admin's GitHub repo, shout out to Nate Wallach and Eric Gomez for their efforts on signing and notarizing the Munki Tools package, and it's available for download. So this is what the package that I use to download. So we're going to take this package. Additionally, on the Munki repo site, we also need to download the Kickstart Munki package. This is going to be utilized to bootstrap the machines into starting Munki out of the box. So we're going to make sure too, in going back to School Manager here, that we assign devices to the MDM instance that we're working with so that we can scope the pre-stage. So going into Jamf, we're going to go back to Computers and Pre-stage Enrollments, and we're going to create a new pre-stage enrollment. That's going to start our zero-touch deployment process. And I like to joke about that because it's not really zero-touch. You have to make a ton of touches before it's zero-touch. So we're going to include the enrollment package that we uploaded previously. On the pre-stage enrollments page, we're going to go to General, name the pre-stage enrollment. In this case, we're calling it ACAD Mac Workflow because it's part of our academic fleet. And you'll see that the ADE instance is the ArcAD academic instance. We have devices automatically assigned here. So the minute that they're assigned in School Manager and that sync happens, they're going to be assigned, or they're going to be scoped to this pre-stage enrollment out of the box. We're going to check a box too that automatically advances the setup process on those machines. We're setting English as the default language and US as the region. So this is so that those lab machines will start out of the box and continue that deployment process. Under Setup Assistant options, we're also going to check all those boxes because this is not being deployed to a particular user, so we're just agreeing to the terms of use in order to use these machines. Then we're going to click on Enrollment Packages, and we're going to add the Munki tools that we uploaded previously. So this is going to be included as part of our base image. If you're using Jamf Cloud, you can click on the Cloud Distribution point, and that's going to be pulled from the Cloud repository. So our Jamf Pro environment is also used by other areas within our campus. So to keep things isolated, we scope the pre-stage based on serial numbers in that site as part of our lab fleet. Once we save that pre-stage enrollment, we're then going to go to policies, and we're going to create a new policy for kickstarting Munki. That's going to bootstrap the computers. So once we do that, we're going to choose packages, upload the package that we uploaded previously, scope this to the computers that are in that site. And in this case, we're doing all computers in the site because we're working with just our lab machines. And that's going to allow us to deploy the thin image to the computers and then bootstrap the Munki tool configuration to these machines. So this is a snippet of what is inside that Munki Kickstart file. So I like to use a package inspector from Suspicious Package. You can see here that the .com.googlecode.munki check install at startup file is created, and it's placed under the user's shared directory, and that's what's going to trigger Munki tools to run at login and give that zero-touch appearance. And something I learned as building this presentation is that Munki tools also offers this in command line. So you can run, as part of your post install, the manage software update --set -bootstrap mode, and that's going to create the file that we just were talking about before. It's also going to turn the disable file vault auto logon preference to true. So that's going to allow you to prevent the login of a user who unlocks the file vault encrypted disk at startup from being able to do this. There's also the clear bootstrap mode, which when it reverts those values back, it changes the Boolean to 0 for the disable FDE auto logon preference. So in our environment, we're not using these. We're still using the Kickstart Munki. It's essentially doing the same thing, but it's something to keep in mind. You have options in your deployment. And the main question here is, so you talked about application packaging. Why not just use Jamf Pro for everything? Well, that's true. You could. For us, it doesn't work, which is why we use Munki. So we have different requirements, and a lot of those come down to some of the benefits that Munki has that Jamf doesn't really have for a lab environment. Some of the stuff that we use specifically it revolves around install scripts. And with Jamf, we have to rely on policies and policy execution logs to ensure that those policies are executed. So to keep our labs consistent, and if we need to make a change quickly, we can rely on the install check scripts, and then those updates are taking place every hour. Also, some of our staff, IT staff, does not have access to Jamf Pro. They only have access to some of the web repositories or some of the package updates. So for a little bit of separation, we have Jamf Pro for management and Munki for the software deployment. So why add Munki into the mix? Well, Munki can run on any web server. It allows for better versioning when compared with Jamf for deployment. It can leverage tools such as auto package for importing into the repo, and it provides a self-service view that can rely on install checks rather than the policy execution logs. So let's talk about setting up Munki. At minimum, Munki needs a web server that has 2 cores, 4 gigs of memory, 100 gigs of storage, recommended 2 partitions, one for the OS and one for the storage, 1 gigabit NIC, and SSH access. I use this every day. Depending on your environment, you may host this in the cloud, you may host this locally, your mileage may vary. The folder structures of Munki include the Munki repo. Under the Munki repo, we have the catalogs. The catalogs are what are used by system administrators to determine which packages can be deployed to the particular group of computers, while denying those packages to another group. So an example of this is like a development and then testing and production. So there are 3 different groups, but each application can be filtered based on which catalog you're deploying. Icons, this directory is mainly used for the Managed Software Center application. I like to keep it updated because it makes the tool that I'm about to show you a little bit easier to see some icons at quick glance. Then we have the manifests. That's what we're going to use to scope the applications to based on the computer's identity. And we're going to leverage the DNS hostname from previously. We're going to create a packages directory, where the packages will live, and then a packages info, which is the configuration for each of those packages. That will include the install check, the pre-install, post-install, any of the settings that need to be customized for that package. Here are some of the resources I like to use when building packages with Munki. So we have Munki admin, Munki import, auto package, which was originally built for Munki, but it was designed so that it could be extended to other management systems. Suspicious package for the package inspection, which we saw previously with the Munki Kickstart package, and then the PKG build binary. So here's kind of an overview of what Munki admin looks like, and this is the packages view. So you can see here that we have a number of packages and they are belonging in different catalogs. So from there, we can actually filter using the left side what kind of category these packages are in and which catalogs they should belong to. If we click on the upper right, there is what looks like kind of a book icon, and that's catalogs. So from here, we can see that we have, right now at the moment, two different catalogs. We have a production catalog and a testing catalog, and we have packages assigned to those catalogs. So what will happen then is that the production catalog will contain anything that we approve for final release to the lab machines. The testing catalog will be the packages that we are testing with. Once we confirm, so everything will default to the testing catalog. We can then add those packages into the manifest that we'll use in a minute here, and that will be scoped to those machines. When those machines check in, they won't be able to install the software because it's not part of the production catalog. So once they're enabled in the production catalog, they'll install. So moving on to the next tab over is the manifest tab. So we're going to build a base manifest for all of our lab machines. Our lab machines start with a base set of software, and then it begins to differ depending on the different majors and different lab requirements. So typically for us, what we do is, because everything follows a building, room, and computer number, we will scope the software to anything that has the site suffix, and then we'll scope based on the lab name, their individual manifest. So to build a base manifest, we're going to set an example here. So in this example, we're setting the catalog to production. The name can be anything that you want, that you seem fit. In this case, I'm using 2024_base, and you'll see that there's no managed installs in this manifest. It's basically because it's just a pointer. It's not the true manifest. So I have notes here in case anyone on my team tries to edit this. Please don't, because this can be confusing. If you click down under conditions, we have a condition here that is the host name of the machine of what it ends with. So I talked about before having kind of a suffix that's part of our fleet. Well, that's because we can use Munki for different environments. For our lab environment, we use the ACAD format. So what we'll do here is we'll change that condition to be .acad.ringling, and then those machines that check in will actually run, they'll pull this manifest and then check the condition to see if the site name matches. And if it does, then it will proceed to the next manifest, which we'll include here in a moment. These are the different options of the conditions that are available. So typically for us, we typically use the host name. There are a few times we'll use the processor architecture. We have some software that's only Intel-based or silicon-based. And date is one of my favorite, because what we'll do is when we lock down a version, we will plan to deploy that version in the labs at a given time. I can use this to set a date of when that goes live, and then on that date, stuff will happen without having to touch all these machines. If we click on included manifest, we then include a true base manifest, which is called our academic base. And you'll see that under condition, you have to click the drop-down menu and then choose the condition that we set previously. So what that's doing is then saying for any machines that have the kind of pointer manifest to reference this base manifest. That allows us to manipulate based on different sites and different host names without having to change each machine's default manifest. If we go into an example manifest, so under referencing manifest, in this example I don't have anything referencing this, but typically what you'll do is you'll add machines into this pointer manifest, and this is going to be a computer. So in this case, I'm using my computer, Keilson-02.ak.ringley.edu, and I'm assigning that to the testing catalog. The included manifest here is that 2024 base, and that is what we referenced previously, and it's going to allow the logic to be consistent across the deployment. The benefit of doing it like this is that we can take this manifest here, for example, the Keilson 02, and duplicate it. And because Munki references the host name, we can use the host name of the machine we can change the duplicate name to the host name, and then that host name is what's going to be called from the client. They have to match. And then the client will pull the reference manifest, which will then go back to the 2024 base and then pull the academic base manifest. So there's 3 manifests in total for your base. So over here, this is the true base manifest that we have. So you'll notice that we have no catalogs checked here, and that's because since these manifests are nested, all we need to ensure that this is set right is for this client manifest to select the right catalog. So in this case, testing, so as it moves through, it's going to use this base manifest that we create here and only reference the items that are under testing. Under manage installs, that's where you include all the applications that you're deploying to your lab environment. For us, Firefox, Google Chrome, VLC, and of course the Adobe Suite. And you'll see here I included an example, but I have a package there, which is the Adobe Creative Cloud Suite, and that's actually going to stop advertising, which you can't see the full date, but it's July 1st. So after July 1st is when we lock down versions, so this will no longer be deployed to machines, new machines. If you go under the included manifest, this is where we create those special manifests for each department, and then we will create the conditions based on the host name, which is the starting with, because we don't need the suffix anymore. We already got to this manifest with that. We'll use that to identify which lab machine and which computers are scoped to different manifests. So in this case, let's open the illustration manifest and look into that more. Under the illustration manifest, I have a note here of the software that I'm including as part of that install and what's defined under that manage installs section. So any machines that were scoped previously back to that base manifest are getting the base manifest plus the additional illustration conditions here, and they'll receive these packages. So going back into Munki admin, we need to save those changes. So we need to click save. Once you modify that manifest, then Munki admin will go through, it'll recreate the catalogs and save those changes. So once you do that, the machines are live. And if we trigger a manual check of the software update, you can see here in verbose mode that it is starting to install the software. At the bottom here, we'll see that we have 4 items that need to be installed, and we can trigger those to be installed manually, or we can allow the launch daemon to run on its own and install them. Here's another view from locally on the machine. of those manifests that we're referencing. Now, unless our technicians know the lab environment and they know which machines are getting which software, they might not see the information that's in Munki. So they'll look this up locally here. But this process can be tedious because they have to either log into the machine and access that information, or they have to remote in somehow. But it's not an easy view. It's not a detailed view. So what I've done here is leverage the extension attributes features within Jamf to take the output here and actually import that into Jamf. So now our help desk team can look into Jamf Pro directly. They can see which manifests are being scoped to which machines. And because these typically don't change all the time, as part of our inventory check, they will update in Jamf. So let's build an extension attribute. So in Jamf, we're going back to Settings, Computer Management, and Extension Attributes. We're going to create a display name here called Munki Manifest, and we're creating a description that's images installed on the computer. The data type is set to string. The inventory detail or display is set to general, and the input type is set to script. Below, we're going to use the script, which you can see here, which is checking to see if the manifest directory exists, and if it does, it's going to list those manifests in this format, and it's going to remove the base manifest from appearing. So that's because we're under the assumption that any machine that's part of our fleet is already getting that base manifest. We don't need to see if they're getting the base. They should be getting the base. If they're not getting into Munki. So we're excluding those here, and then echoing the result. This is what it looks like on the Jamf side. So it won't take effect immediately. It usually updates when the inventory check runs, and then depending on the configuration, this could be weekly. So once that does run, this is what it will look like. So Munki Manifest extension, at the very bottom, you'll see the 2019 illustration and then the Cooley 202.18 manifest there. So that helps us ensure quickly we can look at this and say, okay, this is a illustration lab. It should be getting the illustration software. You can also see, there's some other information that's in here, but the important part is that we can see that the manifest is linked and that the computer is checking in at that time. So encompassing all of this together, I'm going to show a demo of how the pre-stage enrollment looks like. And I hope this will play, because this is, let's see how this works. I've tried to speed it up a little bit, so here we go. And yes, I'm shaking it. I apologize. This process was not easy.
Kind of talk us through each step as it comes up.
So what's happening right now is that automatically advanced step in the pre-stage enrollment, it's going through and skipping each of the steps that is typically required by macOS. So you'll see here now it's on the remote management setting. So it's automatically knows that it's going to be part of that pre-stage enrollment. It's enrolling all of the policies that are set at that enrollment time, and profiles are being deployed. And as part of that, it also installed the enrollment package for Munki. So you'll see here that now it's checking for the available updates, and it sees that we have a package that's ready to install. So it's installing that package as part of the setup. It's installing that package. So for the end user, they won't really see this screen unless we deploy a machine and leave very quickly. Even so, they can't use the machine until this process finishes. They click stop, well, they'll stop the process and they can log in, but they can't use the software. So you'll see there that what it completed was the entire image process. So now a student or faculty can log into the machine and they have access to the software immediately. Now, this computer does need to have access to the internet for that ADE process to take place because it has to enroll with Jamf. If it doesn't have access to the internet or it's stuck, you have to then either connect it to Wi-Fi or connect it to some other network. In our environment, we typically will set the host name of the wired Ethernet adapter. So we have to make sure that the network is working on these machines. If you connect it to Wi-Fi, it will still go through the process, but as one of our configuration processes, we disable the Wi-Fi on the computers. So if you run through that process and it doesn't work, you then have to wipe the computer and restore, or not wipe the computer, you have to log in and restore the Wi-Fi functionality on that machine. Typically that doesn't happen, but it can if you don't follow the DNS naming conventions properly. So some of the deployment strategies that I like to use in this environment is using Jamf for that initial device setup, and then Munki for the app installation. And that's going to allow us to leverage Apple School Manager for the integration of the Zero Touch, and then Jamf to handle the initial pre-stage enrollment and the bootstrapping of Munki, and then Munki is handling the installation of all the packages that we need. Some of our packages require, they need some special configurations. Some of those configurations can be done on the machines themselves, or we might use them for different areas within our Jamf Pro instance. If we use different software in that case, for example, we have Wacom tablets. They need special drivers and profiles to allow the privacy protection and policy control to be enabled on these machines. We don't want to deploy the Wacom driver software everywhere. So what we do is we scope in Munki the manifests or the applications for the tablet installation. We deploy those to those specific labs. When those machines are finished, there's a post-install that then will do a Jamf recon that will update Jamf. There's a smart group that's tied that if it's matching the installed software, it will scope it to the smart group and then install a profile that will allow the privacy protection policy control on that machine or for the Wacom driver. So that will help us improve that streamline. It makes the process of deploying the profile easier, and it takes the time that normally would have to be thought of when you have to deal with multiple lab machines. Now you just have to worry about getting the driver software on there. You don't have to worry about the rest of the steps on it. So going back here, using Munki for the app installation, we need to make sure that all the versions are up to date and the dependencies are nested in there to ensure the compatibility. And that reduces the manual intervention that would typically be manual through the app installation process. Some ongoing management, we're using Jamf for the configuration changes to manage those configuration profiles and the policies to maintain the compliance. We're easily updating the settings, restrictions, and the permissions across all devices. And we're using Jamf to provide that centralized dashboard for monitoring the device compliance and health. So if a device, going back to the manifest, if it's not getting some software, we can then look at Jamf, look at the Munki manifest extension attribute, see that the manifest isn't being applied, and then now we can have proof to go into Munki and find out what is happening. Maybe we'll go into Munki and do or log into the machine remotely. We can run the Munki software update agent, check the verbose logs, and see if it's actually installing. If it's not, then we know where to go from there. A lot of times what we'll have is a new machine will be brought on, and it won't be part of the naming format. So sometimes we'll have machine names that are more than 15 characters long, and because we are in higher ed and we're in a lab environment, we're still binding to AD. So one of our profiles that gets deployed is a AD profile. We've had cases where we've had a name that's longer than 15 characters, and because of the limitations, it will actually cause the AD record to duplicate itself, and then the machines because so as part of the install, the computers are named what their DNS host name is on our environment. If the name is too long, the machines will rename, but because of AD, the script that I have running will actually set the host name and limit it to 15 characters. So if the machine name is too long, then it will limit that name. Then I'll see a bunch of names in Jamf Pro that are the same object, even though they're not, because you can see the IDs. So then you have to go in and either rename them or just reimage the machine. So using Jamf to handle the centralized dashboard is going to be essential in this environment. And then Munki for the continuous software updates, regularly checking to ensure that the software is installed, managing the software catalogs, and ensuring the right updates are deployed to each device, minimizing the downtime by scheduling the updates during off hours, and ensuring the devices are kept up to date based on the conditions and scope provided. Some of the best practices are to assess the requirements, determine what works best for you and your organization. Can you utilize Munki in your environment with Jamf? Maybe you feel that Jamf can do everything. That's fine too. For us, Munki fills that gap where if we rely solely on Jamf, we don't have that. We do have different sites within our Jamf environment. So we have other devices that are deployed to both faculty and students. And in those cases, they do need software that they can install, especially if they're not an admin on those machines. So we'll deploy that software via Jamf. So part of my responsibility is to ensure that both that software software version that we're locking down is available in Munki and available in Jamf. Which is why I like to keep those icons updated, because otherwise I get confused on what I'm updating. Moving on to documentation, we need to keep detailed records of the deployment plans, configurations, and the policies. And that's key for when you need to reference something and why you didn't install, or a subset of computers, why a package didn't get installed, but another machine did in the lab. Sometimes on our Jamf Pro side, we'll use those smart groups and name and have a condition set for those different lab environments. Sometimes we will have a regex that will only store, like, let's say the machines are 1 through 18. If machine number 19 comes online, it's not part of that smart group, so it might not get the right configuration. So we have to go in and change that, or find out if that machine was really just a replacement for one of those other machines. So we need to make sure that the naming conventions are consistent, and that's so that the settings can be deployed automatically to each of those machines. If you manage computers using a standard naming convention, use that for naming your hosts. If you're using a different naming convention, then you can change your setup to use that naming as well. All depends on your environment and what your configuration looks like. Here are some links to the resources that I mentioned before. The first one here, macOS Fuse, is what I use to connect my SSH session to the Munki instance. And because we host that Munki repository locally, I need to use that in order to have that resource available. Questions? Let me try this here.
The Munki repository, and you may have just answered this with Fuse. I don't know what Fuse is. How are you authenticating to the repository from the endpoint?
So
how does the endpoint, how does the server know, right? The repo know that that endpoint is authorized to access it over your network?
So by default, you can leave Munki running as just over standard port 80 and no authentication. We use a local user on that web resource, and then we have embedded in a configuration profile the Munki setting, which is the repository URL, and the authorization token is basically the password embedded in a hash, and that's what's stored for those clients to connect.
Got it.
I'd toss it. Yes.
You said that each machine has its own individual manifest?
Yes.
What actually creates that manifest?
So you have to create those manifests on the web server. So it basically is a text file.
Okay, so you're manually creating them. You don't have a script that's creating them, and then, because we use Munki and Roll,
Okay.
but you're not using anything like that.
No, we're not for the lab environment, because what'll happen is for us when we get machines, they're either going to an existing lab or we're building a new lab. If they're going to a new lab, then we just create those individually, and for the amount of time that it takes to create those manifests, it's fairly simple. So what I usually do is I have a manifest just called template manifest, which is what you saw there without the host name. And I'll just copy that on the web server and just have either like a for loop depending on how many machines I'm scoping it to, and then just clone it that way.
Oh, okay.
Is there any file size limitation on what you can send as a package? I'm currently using Meraki right now.
Okay.
And we tried to do the lab package for Adobe, and it's something like 35 gigs, and it doesn't allow it.
Are you talking about for the pre-stage?
To actually just send it to the machines for the installer.
Break it up.
I'd break it up.
Excuse me?
After enrollment?
Yeah, after enrollment.
There is a tool, and I'm blanking on the name of it. There's a tool that you can use. It's part of the Mac admins. I can't think of the name of it. There's a tool that you can use to break up a larger package like that.
Mm-hmm.
For us, we actually just switched for like Adobe. So our lab environment typically would just get the bulk Adobe install. But what I found with that is that if you install one package from Adobe and it doesn't like that package, it will go back and remove everything. So this year, painfully, I created each individual package, and then I'm scoping that to those machines. It's not fun. Which is typically that's why we do the Munki enrollment package at the beginning, and then deploy, or we bootstrap the configuration and then deploy Munki, just to make that process easier.
Okay, thanks.
Yep.
Behind you.
Behind you.
Hey there. It looks like great work. I noticed that you have Maya as part of one of your software packages.
Yes.
Are you using a license server, or are you having somebody sit at each machine and open the thing and then license it?
We are using a license server.
Okay.
Yeah, so as part of that install, I have a post-install script that then pushes the configuration, and that includes the Maya servers. I was actually building the Windows packages last week and realized that you can customize the install, but for Mac you can't.
Oh, interesting.
So, yeah.
So you
Okay.
haven't deployed it to the server individually, or is your script doing that?
No, so the server is just basically the license server. So all the script is doing is the script is in that PKG's info. It's storing the license server details, and it's just copying those machines to the computer. So when the computer launches, it's checking for, I forget if it's RLM, but it's checking for that license, and then depending on the setup, it's referencing that.
There was a
So.
question over down there.
Question over here.
Here you go.
You don't want to throw it?
You can try throwing it.
Quick question. What's your correlation, like serial MAC address to the host name? Like, are you setting up all your workstation also in DNS when you start configuring?
Yes.
Okay.
So what'll happen is our network, our lab environment is not, it is DHCP, but it's not open DHCP. So machines will plug in, they won't get an IP. What we typically do as part of our inventory process is we'll get a machine from Apple, we'll scan the Ethernet address on the box, and then start our tallying. Basically, we scan the serial number, the Ethernet adapter, and I believe we also scan Wi-Fi adapter, just so we have that information, and then that's stored in an Excel sheet. Then that's sent over to, well, we then define which machines are getting what. That's sent over to our network team, they do the DNS request, and then as part of the setup process, the machines are renamed they do a NS lookup, do a host name check, and then rename the machines that way.
Okay, that's my missing link. Thanks.
Okay, yep.
Thank you.
Yay.
This is going to be how can you tell you work at an art and design school without saying you work at an art and design school?
There you
but
go.
all my questions are about unique products that are most likely also in your environment. We already had one question for the full Adobe CC package, and your answer breaking it up, I think, is
Yep.
a painful answer, but it might be the reality that we all have to.
It's very painful.
Yes.
I don't know another good option. Which for us, like what I'll do is this year I have it under that base manifest and just include everything in there. But it's broken up. And for us too, the other issue is the versioning, because we also run an update server, and that update server.
Rum?
Oh yeah, yeah. I have a lot of words about that.
Oh, yeah. And getting it to go? Getting it to launch?
Getting it to launch, getting the versions in sync. So our lab machines will get the packages that you saw here. The notebooks, so every student that comes in, they get a notebook that's typically, they get their notebook during their freshman year, and they keep that notebook for their 4 years. They also get an iPad too. But that notebook is then pointed to that RUM server, and we're pushing Adobe out through Jamf in that case, because they could be remote, they're not on campus.
Using your cloud distro.
Exactly.
Yes.
And it's easier to manage that way than using Munki for that. But the RUM is a pain, because if we don't update the exact specific version, and because we're art and design, we lock the version down to the T. For example, I have an issue right now where Photoshop, I didn't include or Adobe released a minor update, RUM is not updated, so it doesn't show Photoshop at all. So I have cases where students are like, I can't install Photoshop. Oh, I see Photoshop there. Oh, I don't, because it's not updated. Thanks, Adobe.
Yep.
Yeah, it's a pain.
Okay. Obviously, that's not just me. So I feel like I should probably talk to you after, because my other questions are about like Maxon products.
Yes.
I saw you had the Maxon app and ZBrush as part of your manifests.
And part of the demo was a Cinema 4D. So,
yes. But what I didn't see are the things that are driving me crazy, which are their products that install small plugins in other products, Redshift,
Red Giant,
Trapcode Particular, et cetera, et cetera.
Okay.
And that's where I'm running into the issue with Jamf policy logs, where they're saying failed, 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 but it's really just a lack of some other component. So I think you already answered that question with the extension attributes.
Yes.
Yes. Cool.
Yes, that would be the easiest way to
I
look
think I
at
want to
that.
pass it, because I want to just chat with you after. But
Yeah,
thank
definitely
you so
afterwards.
much. Appreciate it, man.
Of
Yeah.
course.
Anyone?
Any questions? All right. Thank you, everyone. And don't forget to leave feedback.